Good afternoon, you guys. This EdPuzzle is just going to take a look at those exponential function word problems that we took a look at in class. We're going to define those variables, make sure we have an appropriate domain and range, and then just write sentences within the context of our word problem. So I'm going to go ahead and read number one, so I'm not making sure this video is not too long. So it says the most expensive Birkin bag sold for $384,000. The value of the bag doubles each year. They want us to write an exponential equation that models how much the bag will cost after X years and then answer the following questions. So our first task is just to write an equation that's going to model the cost of our bag after X years. So just to kind of refresh our memory, I know that general format for an exponential function is f of x, and that's the same thing as just saying y. These are the same. It's a times b to the x. That's our general format. And a is my initial amount, and then b, that's either going to be 1 plus or minus my r, or there'll be a word in the word problem such as triples, doubles, cuts in half that lets me know what my b is. So let's go ahead and start with the A for this question. So A is just going to be that initial cost of the Birkin bag. How much did we buy it for? We bought it for $384,000. So this is our initial amount. That's our A. And then is there a word in this word problem that lets us know how fast we're growing each year? Hopefully you guys are saying doubles, Ms. Hawkins. Doubles lets us know how fast we're growing each year. And the number that represents doubles is 2. So I'm going to write 2 inside of those parentheses, and then my last piece left is just my exponent of x. So this function here, 384,000 times 2 to the x power, that tells me how many or how much my bag is going to be worth after x amount of years. So let's just go ahead and define our variables. I kind of already said x because I said x amount of years, so I know x represents the number of years. So if you want me to figure out how much the bag is going to be worth in 3 years, then I would make x equal to 3. What about 500 years from now? I would make x equal to 500. So x just tells us the number of years. Why? So we have two things going on in our word problem. We have years going on, and then years corresponds directly to the value of our bag. So that's what y represents, the value of the bag. And that's directly dependent upon what year it is. So now what I want us to do is just make sure we have an appropriate domain and then an appropriate range. So domain, I know that represents my x values. So we just said that x represents the number of years. So we're dealing with time. So if I want to have an appropriate constraint for time, I want to work with those non-negative integers. I don't want to have any negative numbers, because how do I run or how do I calculate negative 5 years? I mean, we just don't measure time with negative numbers. So let me go back. And I want to ask, do y'all iPad just start doing stuff on its own? Because y'all saw how it just exited me out of Notability. So these things kind of crazy. So for that appropriate domain, I'm just going to go ahead and list those non-negative integers. So I'm going to start with 0, comma 1, comma 2, comma 3. And then just to show that the list does continue on and on, I'm going to put dot, dot, dot at the end. So these are acceptable values to plug in for x. Now let's figure out what's an appropriate range. We just said that the y value refers to the value of our bag. And that value is 384,000. That was that initial value. So I know that's going to be included in my answer somehow, some way. So let me ask, should the value of our bag, will it ever be $100,000? Will it ever be $50? And hopefully you guys are saying, no, it can't be anything less than $384,000, because that's how much we started with, and it's doubling every year, so it's increasing. So that's going to tell me that my appropriate range is going to be such that y is greater than or equal to $384,000. So just going back to Unit 1, revisiting those inequality signs, this one right here just means greater than or equal to. Because y can be equal to 384,000. It is in the year 0 when we first bought it. But it's never going to be anything less than that because our price of our bag is doubling each year. So let's go down here to f of 1. We looked at that in class. That just means they want me to figure out what is my price worth, or what is the value that I get back when I plug in 1 as x. So they want x to be equal to 1. And what does that make our function equal? So I'm going to come over to decimals. It's already a is equal 1. A is equal to 1 already. I see that value of that bag is going to be that first number up top, 768,000. So this is telling us that after the first year, the Birkin bag is going to be worth $768,000. And that's what that K represents, 1,000. But I'm sure you guys know that. Because on Instagram, y'all be like 1K, 2K. No, I think I just named 1K. So y'all know that means 1,000. Now let's go down here to the second part. They didn't actually give us the X value this time. They gave us the Y value. And I wasn't trying to use the eraser. They gave us the Y value. So they're telling us that the purse is worth $6,144,000. We need to tell them when. So that's what that missing part here. We need to figure out in how many years is our bag going to be worth $6 million. So I'm going to come over here and I'm going to use my slider and figure out when is it going to be equal to 6 million. And boom, it's right there in 4 years. So my exponent was 4. My exponent is 4. And remember that x represents the number of years. So just putting it all together, after the 4th year, the Birkin bag will be worth 6 million and 6,144,000. And now this f of 0 piece, this is real cool. We looked at this in class. This 0 right here, remember, this x value, that represents time. So we're saying 0 number of years. So that's telling us right now. And I know that if I were to put this in the decimals and make my exponent 0, I would get 384,000 back. So that right there is telling me the bag was worth $384,000 initially. And another word we could say initially is just year 0 when we first bought it. So hopefully that helps kind of clear up any of the confusion that happened during class. I'm going to go ahead and take a look at this next question. The next question says that instead of buying a 10-piece combo, we put $10 into a mutual fund. The mutual fund has an interest rate of 7% compounded annually. Write an exponential equation to model the amount in the account after X years, and then they want us to just answer the rest of the questions as normal. So f of x, let's just go ahead and start there. Let's go ahead and write this equation out. I know that general format is going to be a times b to the x. A is just going to be my initial amount. So for this question, A is just going to represent however much money I invested into my account, how much money I put in. And that amount was $10. So I'm going to write 10 out front. Now, since I do see this 7% on my in my word problem, I want to make sure that I make this a decimal. Let's go ahead and do that first. So what is 7% as a decimal? Hopefully you guys are yelling through the screen, 0.07. So now I have one bit closer to figuring out what my b is, because I know that b is going to either be 1 plus 0.7, I'm sorry, that's supposed to be 0.7, or 1 minus 0.07. I need to figure out, is there something in the word problem letting me know whether this money is increasing or decreasing? But I have to make sure I'm understanding what the word problem is saying. So my keywords here should have been mutual fund, and then interest rate. So these are letting me know that the value is going to be increasing each year. So for that reason, I'm going to do 1 plus 0.07, and that'll make my B 1.07. And then we just have to put our exponent on there. So we have our equation written out. This is something that we're no stranger to. We've been doing this forever. So now we just have to make sure we're defining our variables. So what does X represent? X is going to tell us the number of years it's been in that account. So the number of years is what X represents. Because if I said, tell me how long or how much money my account is going to have after 10 years, you guys would go ahead and put 10 as X. So what that's telling me is that X represents the number of years. Now, when you put that into decimals and it gives you that number back, what does that number tell you? The amount in your account. Oops, I can't spell. Don't tell your ELA teachers. So Y is the amount in our account. X is after how many years. So what's an appropriate domain and range? Let's go ahead and answer those questions. We know domain, those are our X values. We just said X represents the number of years. So we're talking about time. I don't even need to go ahead and tell you guys what our time constraints are, because we know that's just going to mean X is going to be equal to 0, 1, 2, 3, and then we put our dot, dot, dot to show that list continues on. Excuse me. So these are acceptable numbers to put into our function. So I can tell you after 0 years, which is right now, after 1 year, 2 years, 3 years, so on and so forth. Then let's figure out an appropriate range. So these are our Y values. So this represents the amount in my account. So how much money did we put into the account? $10. So I know this is going to be factored into my range some kind of way. So I'm just going to go ahead and list that out here, 10. Now, are we ever going to have less than 10, or are we going to be solely greater than 10? That's what we need to ask ourselves. Is the amount in our account ever going to be less than 10, or is it just going to always be greater than 10? Hopefully you guys say it's always going to be greater than 10, because we should notice that our B here is greater than 1. So this shows us that exponential growth. So for that reason, I know I'm just going to continue to get bigger and bigger and bigger. And since I already started at 10, my Y value is going to be such that it's anything greater than 10 or equal to 10. But I can't have anything less than 10. No one's going into my account and taking money out. I'm just continuing to add and add and add. So let's go ahead and take a look at this f of 1 and then this second question down here. So f of 1 just means they want us to put 1 into our function. That just means evaluate this function for 1. So make x equal to 1. If I were to do so, I would see that this equation should be equal to $10.70. Yes, that's exactly what I see. I wish I could write it, but look in line 3, that 10.7, that's saying $10.70. So that's telling us that in 1 year, there's going to be $10.70 in our account. So over the course of a year, we earned 70 cents, but at least that's better than earning nothing. Let's go ahead and look at this next one. So again, did they give us the input or the output? They gave us the output. So they're telling us that $25.79, that's what's in our account. We need to figure out when. When are we going to have $25.79? I need to just go to decimals, and I'm going to use my slider and see what number is my exponent or x value allows me to reach that value of 25 for the total amount in the account. And let me scoot over so you guys can see. So within 0 to 10, it actually doesn't even reach $25. So let me go ahead and I'm going to make this 20. I'm going to zoom out so I can do so. Changing this number to 20. We're trying to. Okay. I'm not sure why this isn't working with me, but I'm going to go ahead and just try and go up here. Oh, great. Sorry about this. I'm going to try my step with 0 to 20. So I'm going to continue to look for that 25.79. And I see that right here. 25.78. If I were to round that up, I would get 25.79. And I am supposed to round it up because I'm looking at that 5 right there. Remember, 5 or more raise the score. So this is telling me that after 14 years, we're going to have those $25.79. So in 14 years, there'll be $25.79 in our account. Now, what does this f of 0 represent? So this 0, that's telling us that our x value is 0 years. So no time has passed by, so that f of 0 should be equal to 10. And that just tells us we invested $10 into our account. And I just want to make sure that I'm keeping up with that word initially. I want to make sure that you guys are attaching initially to that A value. So we invested $10 in the account initially. That's what that F of 0 means. So there's one more example I want us to look at. It's about some rabbits. So it says, suppose a rabbit population of 5 rabbits quadruples every month. They want us to write an exponential equation to model this after X months and then answer the following questions. We can do that. We've been doing it for 4 times thus far. So what I'm going to do first, just write out what my general format is, A times B to the X. And then I know that B is equal to 1 plus or minus R. Whenever I see a percent, I should kind of think, is this the formula that I should use? So just kind of keep that in mind. But since I don't see any percents here, I'm going to go ahead and use that A times B to the X. So what I'm going to do first is I'm going to figure out what my A value is. And over here I see that A is equal to the initial amount. So I want to figure out how many rabbits did we have in the very beginning. But we know how many. It says a rabbit population of 5 rabbits. So that's how many we started with. And then it says it quadruples every, what was that? I think it was every month. Yeah, every month. It quadruples every month. So I have to ask myself, quadruples means times what? And maybe we can think about words that start with quad. So like quadrilateral. How many sides are in a quadrilateral? Hopefully you guys are yelling through the screen. 4. There are 4 sides in a quadrilateral. And that's exactly what our B is here, 4. And I'm going to go ahead and just do our exponent, which is just X, because we're not sure what our different numbers are yet. So let's go ahead and define our variables. What does X represent? The number of months. And that's kind of typical for X to represent time, something according to time. And then what does Y represent? So what is increasing or decreasing each month? What's changing each month? The rabbit population, the number of rabbits we have. So that's Y, the number of rabbits we got. Let's go down here and look at this domain and range. We said domain is appropriate or all the possible X values. So again, we're dealing with time because it says that X equals the number of months. So what is our domain when we're dealing with time? We'll take any of those non-negative integers. So non-negative means not negative. So 0 is not negative, 1 is not negative, 2 is not negative. And then I'm going to do the dot, dot, dot at the end to let you guys know and let everyone else know that this list does continue on, but I don't have time to go right from 0 to 1,000,000. So I'm just going to put that dot, dot, dot right there. Then I want to figure out what's my range, an appropriate range. So I know that range, for this question, Y refers, let me get my words out. Y refers to the number of rabbits. An appropriate range, I know range refers to the Y value. So they want me to figure out what's an appropriate number for the rabbit populations. So what's an appropriate boundaries? So let's see. We started with 5. So I know that's going to be factored into my appropriate range some kind of way. So I want you guys to think about that A really critically because it's telling us something. So I'm going to go ahead and write that 5 down because we have 5 rabbits to begin with. Now, are we ever going to have 1 rabbit, just 1 rabbit? No, because these rabbit populations, they're quadrupling every month. So we're just going to get more rabbits, more rabbits, more rabbits. So an appropriate range for this one would be such that Y is greater than or equal to 5. And I want to just make a note here that these are going to be integers. Because I can have 5 rabbits, 6, 7, 8, 9, but I can't have 7.5 rabbits or 3.2 rabbits or parts of a rabbit. So I want to make sure that I'm using those whole numbers, those integers. Now let me come down here because we're ready to go ahead and evaluate. It says F of 1. What does that mean we should do? We should plug in 1 for X. So I'm going to come over to decimals, move down a little bit so you guys can see. And right here, I already have an exponent that's equal to 1. That value is 20. F of 1 is equal to 20. So that means that in 1 month, there are going to be 20 rabbits. So we can see that this rabbit population is growing a lot faster than our mutual fund account from the previous question. Now let's go down to that next line. It says F of blank equals 320. So this is the number of rabbits, 320 rabbits. We need to figure out when does that happen. So I'm going to go over to decimals, and I'm going to slide my slider, and I'm gonna look for my equation in line 5 to be equal to 320. And boom, it is. So in 3 months, because my exponent was equal to 3, they're gonna be 320 rabbits. So we can see they're growing really quickly. Now this f of 0, that one will be equal to 5. Because what does this mean? We had 5 rabbits initially. And I'm using that word initially because I want you guys to associate f of 0 with initial amount, initial position. So that's actually everything for this EdPuzzle. So I thank you guys for your patience. I'm sorry that we didn't get a chance to finish this in class, but I want to use these EdPuzzle times as a way to just continue whatever we didn't get a chance to go thoroughly over in class. So here's the end of that exponential function word problem EdPuzzle. You guys have a great rest of your day.